Today we're going to be simplifying some expressions, and so I want to remind you that we have these exponent rules that we learned that are in your posters under the reference materials. So remember, if it's a multiplication problem and the bases are the same, you can add the little exponents. If it's a division problem, you can subtract them. If it's got parentheses with an exponent on the outside and it's just a single monomial inside, then you multiply the exponent outside times all the exponents inside. So anyway, I just wanted to remind you about that. And of course, we don't leave them with negative exponents. But today, simplifying. So this is a lot of stuff that we've done. This first part I crossed off is just a bunch of stuff that we don't need to do. But we want to do this, simplify the following expressions. So look to see, are we adding or subtracting or multiplying? This is an adding problem. None of those rules dealt with adding, okay? They were multiplying and division rules, right? So if it's just adding, I'm just combining like terms. Are these like terms? Yes, they are all x's to the first power. And what is the number in front of them? It's a positive 1 and a positive 1 and a positive 1. So I've got 1x plus 1x plus 1x plus 1x plus 1x. So count those. 1, 2, 3, 4, 5. This is simply 5x. The x's don't change. It's not going to become x to the fifth power. It's just adding the numbers in front. So there's your combining like terms. That answer is 5x. Okay, skipping up here to the next column. What operation is happening between these x's? This is multiplication. This is where I do follow those rules where it said to add the exponents. And what were my little exponents up here? They're a bunch of little ones. So if I add all these little ones, this is where I get x to the fifth power. Okay? There is the answer on that one, right? X to the fifth. When you multiply, you add the exponents. Now, is this multiplication or addition? This is addition, so this is combining like terms. So part of getting better at this now is flipping back and forth between them and recognizing which set of rules to follow. So this is an addition problem. I am not going to add the little ones and get x squared, right? This is like terms. Are they like terms? X to the first, yes. So 2 somethings plus 3 somethings is 5 somethings, right? There's the answer to number 17, just plain old 5x. Now, is this an addition problem? No, it's a multiplication problem. And if the bases are the same, the x's are the same, then I can add the exponents. So this is x to the fifth. I'm going to put a little equal sign there, okay? So this one is x to the fifth. Whoops. So there's my 18. There's my answer on that one. Okay, now this one, I see plus signs all in here, okay, right? But I can only combine like terms. So this one can go with that one. These can all go together, right? So what's 1 something plus 1 something? I've got 2 somethings. And I have a positive 1 and a positive 1 and a positive 1. So altogether I have a positive 3 other somethings, right? There are those. So 2x plus 3y, can I add those together? No, they're not like terms, and that's as far as you go. That is as simplified as it gets. All right, we got multiplication, right? But remember, I can only multiply the x's together, and I can only multiply the y's together. So when I multiply the bases that are the x's together, I'm adding the 1 and the 1, so this is x squared, right? And then I've got y times y times y, so 1 plus 1 plus 1. You have little ones up there, right? Little 1 plus little 1, because we add the exponents when we're multiplying. So this is y to the third power. There's still technically a dot between it. You don't have to put the dot. You can just smush them together. X squared y to the third is the answer to that one. Okay, so this one you got to really pay attention. This is a multiplication problem, but this is an addition problem, and these are being multiplied. So remember PEMDAS, we do multiplication first. So we're going to do this multiplication, and we're going to do this multiplication, and leave the plus sign between them. So when you multiply, you add the exponent. So x times x is x squared. I'll put a little equal sign here so we know that that's where that starts. Okay, so that one's x squared plus. And then when I multiply my y's together, I've got a 1 plus a 1 plus a 1, so this is y to the third. So this is x squared plus y to the third. If I'm adding, they have to be like terms. Are they like terms? No, they're not. So that's as far as you go. X squared plus y to the third is the answer to that one. Okay, so hopefully this is coming back to you. At whatever point you want to stop the video and go work some problems on your own, obviously you should do that and then come back and check your answers. All right, so again, multiplying here, a plus sign, multiplying. So we're going to do, PEMDAS says do multiplication first. So if you multiply the 3 x's together, 1 plus 1 plus 1, I'll write this one below it, x to the third, plus, and then y times y, add the 2 little ones, and you get y squared. Now, this is an addition problem. Are they like terms? No, so that's as far as you go. That is the answer. This is as simplified as it can get. Okay, so here I have this lovely parentheses with a plus sign and a bunch more parentheses. So I'm thinking, always do what's inside the parentheses first. Are these like terms? Well, by golly, this time they are like terms. The x squareds can all go together. So I've got one something plus one something plus one something plus one something. So how many somethings do we have? 1, 2, 3, 4. We got 4 x squareds, right? Plus, let's go do the other parentheses. Can I do what's inside? Oh, look, they are also like terms. Again, I've got a 1 something plus a 1 something plus a 1 something. So this is plus, where's my plus in between? This is 1, 2, 3, 3x squareds, right? Okay. Now, are these like terms? They are, so I can add them together. What's 4 something plus 3 somethings? That is 7x squareds. So the whole thing simplified down to simply 7x squared. They were all x squareds being added together. Okay, next one. Again, parentheses with a whole bunch of things inside minus a single something. So again, parentheses first. Are they like terms? Yes. And since we're adding, I can just add up all those front numbers. 1 plus 1 plus 1. So let me just count. 1, 2, 3, 4, 5, 6. I got 6x squareds. And then a minus sign. And an x squared. Now, in order to add and subtract, are they like terms? Yes. So what is 6 somethings minus 1 somethings? That will be 5 somethings, right? So 5x squared is the final answer to that big long thing up there. Okay, here's another one. A bunch of adding. And remember, we can only combine like terms. So here's an x cubed. Oops, there's an x squared. And here's my lonely little x all by itself, right? So these can go together. 1 plus 1 plus 1 is 3x cubes. And then I've got x squareds. One of these plus one of these is plus 2x squared. I'm going to run out of room. And then plus 1x. Now, are any of these like terms? No, even though they're all x's. This is x to the third, that one's x squared, and this is x to the first, so they're not like terms. That's as far as you can go. You got to stop there. Okay, multiplication problem again. Remember what do we do with our exponents when we multiply? You add them as long as the bases are the same and both of them are x's, so we can multiply them together. So this is x to the 14, and it's a positive exponent, so I'm happy leaving it just like that. Another multiplication problem, and there's no exponents on the outside of the parentheses that I have to do the power rule, so I'm just multiplying these two things together. Remember, big numbers, the big coefficients multiply as normal. 2 times 3 is 6. And then what do you do with the exponents? You add them. So x's and x's can be multiplied together, and 3 plus 2 is 5, so this is x to the 5th. So this is just practicing going back and forth between the adding, combining like terms, and then multiplying rules. Another multiplication problem, right? But this is not a monomial. This is a binomial times a trinomial. There's 2 terms here separated by the plus sign, and there's 3 terms here. So this is where you do that double distribution. This has to be distributed to that, then it has to be multiplied times that, and then we got to multiply it times that. And then we're going to come back and multiply this one times the first one, that one times the second one, that one times the third one. So let's do the first piece first. x3 times x squared, we're multiplying. So what do you do with the exponents? You add them, so that's x to the 5th. And then I do x3 times x squared again. Oh, you know what? Could we simplify this thing inside here first? Oh my gosh, yes we can. This is going to make this easier because I always tell you to look for like terms. Are these like terms over here? They are. So let's scratch what I was about to do with all that long stuff. Always do inside parentheses first if you can, right? What's 1 something plus 1 somethings? That's 2x3. And so I'm going to put parentheses around that one. And then this one, I've got x squared plus x squared plus x squared. So 1 plus 1 plus 1 is 3x squared. Oh, this makes this way easier. Now it's just one single multiplication problem, right? 2 times 3 is 6, and x3 times x squared is x to the 5. Oh, I'm so glad I noticed that because I always tell y'all you're looking to do the parentheses first. Okay, so again, we're adding, but we always look inside. Can you do what's first? Inside parentheses? No, they're not like terms. Not like terms. Okay, but it's just an addition problem. So all I got to do is get rid of parentheses. And what number's sitting in front of this? Positive 1. When you distribute a positive 1, does anything change? No, it stays just like it is. And there's a 1 in front of this. And when I distribute a positive 1, does anything change? No, it still stays a positive 1x. Still stays a positive 2y. But now the parentheses are gone. You can combine like terms. So x's go together. So 3 plus 1 is 4x. And then 2 plus 2 is 4y. And those are not like terms. That's as far as you go. Now, this 42, it looks like it's going to be hard, but it's really not. This is a fraction, and this is multiplication between this fraction and this thing over here, right? So just put in parentheses, because if you were to subtract or add x plus y, it would give you 1 something there, right? So remember when we were doing our fractions, if we had a whole number times a fraction, we made our whole number into a fraction, so I can just multiply straight across the top and straight across the bottom, right? So 1 times x plus y is still x plus y, right? And then 1 times x plus y is still x plus y. Remember, I always tell you put parentheses around the polynomials. It just kind of helps you kind of see them together. So now I've got x plus y over x plus y. Is that the exact same thing on top and bottom? Will they just cancel each other out? They will, and just becomes a big old 1, right? Anything divided by itself is 1. Perfect, there we go. See how easy that was? So it's just following your rules of fractions. When you're multiplying fractions, you multiply straight across the top, straight across the bottom. Since that was just like a whole number, I can leave it on top and put a 1 underneath it, make it into a fraction. Okay, so now we've got a subtraction problem between these two. We also have multiplication on either side. So PEMDAS says do multiplication before we do the subtraction. So we're going to multiply these two together first. Remember, multiply the big numbers. 4 times 7 is 28. And then x times y is just xy. I can't actually do anything other than just smush them together, right? Minus, now this is a 3 times just a 1 over here, so this is still 3. And x times y is still xy. Here we go. So now I have 28xy and negative 3xy. Are they like terms? They are. We can't combine them together. So 28 minus 3 is 25xy. Here we go. And then last one on this one, multiplication problem. So we're going to multiply the big coefficient numbers 2 times 5. And then if the bases are the same, x's, we can add the exponents. So 3 plus 5 is 8. Remember, you add exponents when it's a multiplication problem, and there's the answer to that. So there is your review on simplifying expressions. All the things that we've been doing this year and learning kind of all comes together with that. You're going to be doing lots of that next year in geometry and in algebra 2. Back to our complementary angles. Of course, we're looking for, well, complementary means that they add up to what? 90 degrees, right? So this little piece of information you need to have memorized now is that complementary means they add up to 90 degrees. So this big angle is 90 degrees because you've got this little box here in the corner. So this angle plus this angle equals 90. So if I take 90 and subtract 26, I will know what this is equal to. Although they didn't ask me to find the value of the other angle, they asked me to find the value of x, and x is inside this thing here. It's x plus 10 degrees. But the first thing you want to do is go ahead and find out what is the measure of this angle. So if I do my 90 minus 26, okay, 6 from 0, I can't do that, but I can do this. And by the way, if you want to use a little calculator, you can. You can just put in 90 minus 26. I'm just going to remind you how to do it by hand. 6 from 10 is 4, and 2 from 8 is 6. And of course, the other way you could have done it was said I needed 4 more to get to 30, and then from 30 to 90, I needed another 60, so that also gave me the 64. So this is equal to 64 degrees, right? Okay, so that means x plus 10 equals 64. If you're looking for a variable, and they don't give you the equation, you need to write your own equation that has an x in it that then you can solve. So anytime you're looking for a variable and they don't give you the equation, you've got to write your own equation. So in geometry, you have to know your geometry rules and not rules, and kind of things like the 3 angles add up to 180 degrees in a triangle, and things like complementary add up to 90. So we're looking for those things to see what we can do. So the easiest one that we can do here is for an equation is just say 64 equals x plus 10, because this is they're saying that x plus 10 degrees is the measure of this angle, and we know that it equals 64. So I'm just going to write this little equation, 64 equals x plus 10. Okay, so now that we have an equation, can we solve for x? Yes, because that's what they wanted us to do, was just find x. But we needed to find this along the way so that we could make an equation. So in order to get x by itself, I need to subtract 10 to get rid of the 10. If I do it to one side, I must do it to the other side. So remember, the goal is to get x by itself. So whatever number is over here is the one I want to get rid of. So when you subtract 10 on both sides, of course, that means x is now equal to 54. So what is x equal to? 54. There you go. And if you take 54 plus 10, you get 64, which is what we knew that angle needed to be. So we're just doing some easy little solving ones today, making our complementary angles just slightly harder than what they used to be. So again, these two add up to 90 degrees, so that one's 40. This one must be 50 degrees. So there's my equation, 50 equals x minus 2, because they're telling me that this angle is equal to x minus 2 degrees. So 50 equals x minus 2, right? And then, of course, we want to get x by itself, so we add 2 to both sides. Boom. That's now gone. X is equal to 52 degrees, right? Or x is equal to 52. So x is actually not the degrees. X is just 52, but 52 minus 2 makes this 50 degrees, which is what we want it to be. Okay, so pause the video if you haven't already and go ahead and do the rest of these. It's just one page of these, and then come back and check your answers. Okay. Hopefully you are paused the video, and now you're going to come back and check your answers. Here we go with checking the answers. All right. Now on this one, it was interesting because this was a fraction, right? But still the same thing. This one was 72 degrees, so if you take 72 from 90, it was equal to 18 degrees. So I set up 18 equals x over 2. Now, this was a division problem, so how do you undo? I want to get rid of this 2 because x is over here. One way to do it is to multiply both sides by 2 because that undoes division. So the 2's are now gone and x is equal to 36. So that's one way to do it. You could have also said, ooh, this is a fraction equal to, but instead of leaving it as a whole number, you could have put it over 1, right? So this is a fraction equal to a fraction. Could you have done the butterfly method? Absolutely. And we're going to practice these a lot one day in not too near future of setting up fractions equal to fractions in these geometry problems. We're going to do that when we have similar or proportional problems. So anyway, x over 2 equals 18 over 1. So if you multiply 2 times 18 together, right, and 1 times x together, they're equal to each other. This times this is equal to that times that. So here's my 1 times x is equal to 2 times 18. Now the good news is x is already by itself, and 2 times 18 is 36, which is what the answer is. Because whether you did it this way or you did it this way, you got x is 36. Okay, so there, I just want to show you that one real quick. All right, the rest of these will be much faster. That was number 3. Number 4, of course, this angle is equal to 60, so there's your equation. 60 equals x minus 5. You solved it and you got 65. This one, the angle was equal to 24 degrees, so that means 2x equals 24. And of course, you solved that one by dividing by 2, and you got x is equal to 12. 6, that was 15, so this one was equal to 75 degrees. So when you set up your equation, solve for x was 70. Number 7, this one was 46 degrees, so this one was 44. So 44 equals 4x, and then you get x by itself by dividing by 4, and of course, x was equal to 11. This one was 59 degrees, so this degree over here was 31. And so 31 equals x minus 13, and then you added 13 to both sides, and x is 44. And the last one, this was 33 degrees, and so complementary angles means this one is here is 57 because they added up to 90. And then set this as your equation, 57 equals x plus 17. Subtract 17 on both sides, and boom, there was your answer. Okay, so those should have been nice and straightforward, easy problems to solve. That kind of gets you in the, what we're going to be doing more so the rest of this year and also for next year for geometry. All right, see you guys tomorrow.